All right, welcome back. So you should have been able to graph this line y equals 2x minus 2. Notice we started at -2 on the y-axis because that is our y-intercept. And then our slope was 2 over 1, right? Any whole number, just like we talked about in the previous video, can be put over 1, okay, in order to make your slope a fraction. So basically that means up to right 1, and I did that until I filled out the entire screen, okay, the entire graph. Now, I found the intersection point to be 4, 6. I circled that. I labeled it. All right. All good things to do. Did I stop my line there? No, I continued. All right. It's important, just like we were talking about for this entire unit, when you graph a line, find all the points on that line that would fit on the graph. Okay. It's just good for completion purposes. So our solution here is 4, 6. Now, what we're going to do in this lesson is we're going to see how, just like when we were talking about slope, and you can find slope algebraically using the slope formula, we are going to show how you can find the solution to a system of equations using algebra if you're not given a graph. So we're going to take these same two equations here for exercise number 1 continued, and we're going to solve the system of equations algebraically using the substitution method. Okay, and I'll tell you what that means in a second, but we should be getting this answer 4, 6. So we should get our x to be 4 and our y to be 6. So how does this work? Okay. This is what I want you guys to notice, okay? First of all, we have two equations of lines here. We have y equals 2x minus 2, y equals -x plus 10. These are both equations of lines, okay? Notice they both have this at the front, y equals. Now, what does an equal sign mean? It means that this side is the same as this side. Same thing with this side is the same as this side. That's what an equal sign means, right? So these two equations are telling me that they are both equal to y, okay? So this is where substitution method comes in, okay? So basically what this means is I'm going to set these both equal to each other, because if they're both equal to y, they're both equal to each other. What does that mean? That means that this thing here, let's do a different color. This thing here, this 2x minus 2, is equal to this thing here, because they are both equal to the same value, which is y, okay? So putting that all together, that tells me that I can do what's called the substitution method. I can set them equal to each other. That's what math talk, math teachers will say. Set them equal to each other. So what does that mean? So I have my 2x minus 2, and I'm going to say that that is equal to -x plus 10. Whoa, okay? What did I do here? I took this side of the equation, and I took this side of the equation, and I pulled them down here. Okay, I got a whole lot of arrows and stuff. It's starting to get a little confusing. All right, there. Okay, so what I did was I took both sides of the equations and I put them together with an equal sign in between. Why am I doing that? I'm doing that because I want to find the x value where they're both the same. So what I'm saying is assume that both of the y's are the same. So assume that this y is the same as this y, okay? If those both y's are the same, I need to figure out what is the x that makes that true, because we're trying to find a point, right? Our point we know is 4, 6. So what I'm saying is I need to find the x value where both of these lines intercross. Look at where x is. If I follow this line here, okay, I'm at 0, 0. My x value, whoops, don't want a circle. My x value is 1, 2, 3, and 4. It's right there, right? So the x value is the same and the y value is the same for both of these lines at this point. I need to find that point algebraically, given that I don't have this graph, okay? So if I'm just doing this algebraically, what I'm doing is I'm setting them equal to each other, okay? This is a new concept, something that we haven't looked at before. So it's going to be confusing when we start, okay? Now, you got to think back to last unit, all right, when we were solving equations with one variable. We now have an equation here. This equation only has one variable. It doesn't have y in it anymore. There's no y's. There's only x's. And I need to find what x equals. So I'm going to do some calculations. Okay, I'm going to do some algebra, some manipulation, and I'm going to get to a point where I have x equals and then some sort of number, right? Okay, so think back to last unit. All right, in the beginning of the year, we were solving one-step equations. What did we do? We were solving two-step equations. We were solving variables on both sides. We were solving variables on one side. All those different strategies, they're coming back into play now. So what am I noticing about this equation? I need to get down to x equals. I have a whole lot of stuff going on. I have four terms. If I separate them, okay, I have this term, this term, this term, and this term, and I have an equal sign in between. The first thing I need to do is to make sure that I have variables only on one side. So if you remember back, we can only have variables on one side because I need to get down to here where it just says x equals something. So I can't have variables over on another side, right? I got to keep them on just this side to the left. So what I'm going to do is I'm going to get rid of one of them, and I'm going to get rid of the negative one if there is one. Here's a negative x. How am I going to get rid of it? Well, remember, equations are balance beams, right? So I can't get rid of it by just deleting it, right? I have to balance it out. So if I'm going to get rid of this negative x, first of all, the opposite of a negative x is a positive x, right? So I'm adding x. And if I do that to one side, I have to do it to the other. So this is good review of things that we learned in Unit 1, right? Adding x to both sides, I'm making sure that I'm doing it to both sides. And if I do that, then my equation still stays balanced. I'm not tipping it over, okay? Negative x, positive x, those are opposites. They cancel out. All I have left is my 10. Hopefully this is starting to come back to you guys a little bit. Okay, so a 10 on this side. Over on here, I've got two x's plus an x. That gives me three x's. Okay, so we've got three x's here minus 2, and that is equal to 10. Remember, equal sign on the line, equal sign on the line. All right, hopefully this stuff's coming back to you. This is starting to look like what we talked about in Unit 1, a two-step equation, meaning there are two more steps to finish this out. We always do the first step, which is some sort of adding or subtracting, right? I got to get rid of the number that's being added or subtracted. So in this case, it's this minus 2. How do I get rid of a minus 2? Well, what's the opposite of minus 2? Adding 2. If I do it to one side, I have to do it to the other. Okay? So again, I'm keeping everything nice and straight. I'm showing all my work. Hopefully this is starting to come back to you guys a little bit. Okay, these are opposites, so opposites cancel. All I have left is my 3x on this side, so I'm going to bring that down. Okay, and so 3x is on this side, right? What do I have on the opposite side? Well, I have to figure out 10 plus 2. That's easy. That gives me 12. Okay, so I'm very close to being done. I was in a two-step equation, right? And I've now completed one of those steps. So clearly I have one more step in order to make this, in order to figure out this equation, right? What this x is. So how do I figure out 3x equals 12? Well, remember, the last step in a two-step equation is always either division or multiplication because we go backwards in our order of operations, right? So we got to figure out, how do I get rid of this 3? Well, what operation is happening here? Is this 3 times x or is this 3 divided by x? Well, I don't see a division sign, so it has to be multiplication, right? It's invisible. What's the opposite of multiplying by 3? It is dividing by 3. So I need to divide by 3 on both sides. Okay, so I'm going to divide by 3. And 12 divided by 3 I know is 4, so my x equals 4. Now, is that what I was supposed to get? Let's come back up here. Is my 4 the x value in this solution? Yes, it is. Okay, 4. So I should get a 6 when I find the y, but how do I find a y? Like, I'm done, I thought. Am I done? No, because a solution to a system of equations is a point, right? But if you only get the x value, you're only getting half the credit. You're only doing half the work. You're only getting one part of the solution. You're getting this part. You don't have this part yet. You don't have what's in here yet. You don't have this 6, okay? You're missing that, all right? So we need to find that second portion of it, the y value. How do I do that? All right, so here is another step to the substitution method, and it is to plug in your x into one of the equations, doesn't matter which one, simplify it, and you will find y. Because notice, these equations say y equals something, right? So if I got a number over here out of this 2x minus 2, if I was able to get just a number out of here, that would be my y value, right? Same thing here. This is y equals something, right? All this stuff. If I get this simplified into just a number, that number is my y value. So it doesn't matter which one I choose. I'm going to choose this first one. So let's rewrite this equation here. I'm going to bring it down. Okay, I'm going to rewrite it. So it was y equals 2x minus 2. We've been working with this equation for a little bit now. And what I'm going to do is I'm going to do the substitution method, meaning I'm substituting my variable in. I'm going to take the x that I found from my previous, and I'm going to put it in for x here. I'm substituting. Okay, so that becomes a 4, and then I have my minus 2. Now I'm using my order of operations to simplify this. So order of operations say I have to do this multiplication first. So 2 times 4 equals 8, right? And then I've got 8 minus 2. That gives me y equals 6, which is what I was supposed to get. Remember when we did it graphically, we did figure that out to be 6. So my solution to the systems of equations for this equation, for this set of equations, is 4, 6, which we did know, all right, from the previous problem. Okay, that was a long video, a lot to unpack. Many math teachers refer this technique to setting the equations equal. Okay, so we took these equations, we set them equal to each other. We found the x value. We took that x value, we plugged it in to one of the equations, didn't matter which one, we just chose one. We plugged it in, substituted, simplified, and got our y value. So you need the x, you need the y. That's the point. That's the solution in the system of equations. And I will see you in the next video.